Welcome to Tech Math B52, Mathematics for Career Education. We're looking at lesson 4.4. In this lesson, we're going to look at log scales, their magnitudes, relative change, and logarithms are actually used for earthquakes, so that's one of the real-world applications we'll see. The first one we're going to look at is carbon dating. Carbon dating is one method scientists use to determine age of different artifacts. So it's a radioactive decay. So let's look at number 1. And we're looking at a tree. It has 1 unit of carbon-14 at the time it dies. So we have to use the formula from above, so that A equals 0.8861 to the power of t, to give values. So we have t is for every 1,000. So I'm going to put 0.8861 to the second power because we have 2,000. So the next one would be 0.8861 to the fourth power, then to the sixth power, then to the eighth power. And then I would plug those into my computer, my calculator. And for the first one, I get 0.785 round to the 3 decimals. So for number 2, we're looking at textbooks, and the half-life of carbon-14 is 5,730 years. So half-life would be half, right? Half the life of something. So let's use that idea of half-life. 1 divided by 2 is half, so 0.5. Divided by 2 again, that's 0.25. So we're going to keep dividing by by 2 to get our answers. Now number 4, we're going to finish that table, and 20% is about 0.2. So 20%, if I'm looking at the table, is in between 11,000 and 17,000. So if I'm going to guess, I would say maybe 13,000 years old. For number 5, an artifact is found and it has 20% of its original carbon. So then A is going to be 20%, or 0.20. And we're setting that equal to 0.8861 to the power of t. And what we have to do is solve for t. Another use is log scales. So when we're thinking of really big or really small numbers, logarithms might help. Now, if you've been watching the news, you'll see logarithms are used for high populations as well. So you'll see a logarithmic versus a linear scale. If we're looking at planets, those are really big numbers. So we can use a logarithmic scale. We can use the power of 10. So here we have 10 to the 3.5. So if we guess 3.74 is where Pluto is at. So then 10 to the 3.74 is the millions of kilometers we would say Pluto is away from the sun. Okay, so then we plug it in the calculator and we get 5888. Next, so Ida, or Ida, I'm not really sure, is a large asteroid in the asteroid belt. So it's 10 to some power. Once we plug that in the calculator, we get 429. So I have to take the logarithm, or the log of both sides, and that allows me to get rid of the log of 10. Now I do, in my calculator, log of 429, so x is about 2.63, so it's a little bit past 2.5. Now here are 2 different charts. Now you'll see these a lot in the news, right? Where you can see the lines are a little bit different. So there's absolute change and there's relative change. You want to make sure you understand the difference between absolute change and relative change. So absolute change is where you're just subtracting. Relative change is where you're subtracting over time. So if we just subtract, for 1929, it's down 338. Now if we divide that, it's down 88.9%. So if we look at 2008, the market drop, absolute change, we're subtracting the new minus the old. You can complete the questions.